Well, here we are. I'm going to start the next part of this. We're going to try to figure out why it's got all that noise.
70% on heating and cooling. There's a 30% renewable energy tax credit and for a short time.
You can tell it's got a lot of distortion in it. Now, I have been through this thing as far as voltage checks. One of the big issues, most of the voltages are well within decent tolerances for using a digital meter. That's generally what I use, unless it's really something specific. I really need to use the VTVM or touchy circuit, except for one set of voltages, and that boils down to, hopefully I can get this where you can see it, but when we go down in here, and what I'm checking is the AVC line, which supplies the grid voltages for both the input grid or control, what is actually known as the real control grid for the mixer tube, as well as the IF amplifier tube. And I'm getting minus 0.4 volts. Now I managed to get it up to this. It was running around minus 0.2, and it should be 0.7. The interesting thing is there's a drop across this resistor that sets in there between the detector diode and the AVC diode. There shouldn't be. So that resistor might have to be checked. But what that ended up doing is, I believe that's probably what's causing the distortion. Now, one thing we can do is try to trace some of it, and it turns out the signal is relatively weak enough once I get to the mixer tube between that and the power supply hum that's in the radio that's inherent in this. I'll probably on the next video kind of go over why these style radios a lot of times have power supply hums, but real quickly is you're running a half wave rectifier, and then you're running 2 pi networks, and actually only just 1 pi network a filter that actually goes up the audio transformer and then to the output tube. Just 220 ohm resistor and fairly low capacitance. When you got this style filter, they're not really good, especially with a half wave rectifier. I'll go over that later, probably in another video after this. But what I can do is to make it a lot more obvious. I can hear it myself, but what I can do is we can actually go in here and apply a signal ourselves, and we'll bring this thing up to pretty much max. So we got, now it's in there now. You hear it's distorted. Now if we take the signal tracer and we hook it up, and we'll pick our common down here, and if I come out, well, we'll start at the down low here at the AVC circuitry. Noisy, distorted. If we move on up, and what that is that's pin 2. We started here, and now we're measuring here, going backwards in our circuitry. still has some distortion in it. It's there. Well, let's take it on back. We'll go to its input, the grid. At this point, let's see what we got. You can hear it better there. All I'm doing is just turning the volume up. If you don't, these things are so sensitive. Every time I move the pointer or the deal, it'll make a heck of a lot of noise. Now that's got enough power coming out of it, I don't even have to turn it up. Nice and quiet. Beautiful sound to it. And where I went just then was pin 2, the mixer tube, the output, going in here. Now, one might suspect at this point that we have a problem with somewhere between these 2 points. And you would be correct under normal circumstances, except for the fact that where I pulled off the signal from was the ABC, and also the fact that the ABC is low. Now, to test to see if that low signal, ABC voltage, can cause some problems with some distortion, what we'll do is we'll disconnect this stuff, and what we can do is we can add voltage to the ABC circuit. Now let's see what that does for us.
Clearing tomorrow, 46. That's the latest weather forecast from Channel 13. I'm in Wilson this Wednesday at Toys R Us. Rewards are
okay, we got the volume up. Now we want to make sure we get this connected right. We go down here, ABC, hook up to it, the battery. That's the negative end of the battery. And I'm on just now connect to ground.
WHO. Views expressed are those of hosts, guests, and callers, and not necessarily those of News Radio 1040 WHO.
Nice and quiet. Now, for your test, you guys want to test. If you want, see the difference? For your test, okay. For your test, explain to me why that makes a difference. I mean, all I'm doing is increasing the negative voltage on the grids of the IF tube, and of course also the mixer tube. In other words, I've increased the ABC voltage output. Why will that make a difference? Now the next point here is there's something wrong here, and my suspicion really boils down to it's not in this first IF can. When I'm picking up a signal here, what actually I'm picking up is a distortion, some noise and distortion that's coming up through here from back here. And what I really believe is going on is, and why we're not getting the voltage, we're not getting our diode voltages. And so there's got to be something going on inside this circuit. Now I know this resistor is good, because anytime you do a restore, you always want to check this resistor, make sure it's in tolerance. This is the load resistor, and you want to make sure that it's in tolerance, and it was out of tolerance, so I changed it. And of course you always check your volume control, make sure it's alright. So my guess it's this IF can. Now on the next video I'll go ahead and pull the IF can out. On the next video we'll tear it apart, see what we can find, if anything is wrong with it. If there's something wrong with it, maybe we can fix it, maybe we can't, but we'll see where we're at there. If we can't fix it, I've got one I believe will work in it from the same error. It's another 455 can. It's even Philco, so I think that'll work. But why does low voltage, or depending on how low negative voltage, closer to zero, let's just say it that way, is going to affect this and possibly cause a distortion to flow through and then be picked back up? That's your question, if you want to try answering. Thanks for all your support and the very, very kind words from several of you in your comments. I really, really, really do appreciate them. I'm going to get some of them answered, I promise you. But just keep watching, and hopefully we keep having some information for you, and we all keep learning. And until the next video, thank you for watching, and thank you so much for your comments.